Here's a stock check of the strange things on this page. So I highlighted them all there in little dots, so let's just go through this. Now the artwork at the top plays very little part in the geometry, even though the roundels on the monster's eyes I'm convinced must be part of the geometry, but I can't find out what. The mouth of the goddess here is perfectly defined, as is the left rabbit's eye, but the right one is nudged in slightly, and there's a nuance there, so I haven't bothered labouring any of that. But that's just to say that this artwork is actually plays very little part in what I've so far discovered. So let's get on with the text, because that's where it's all going on. And we start with this S, which has here a square dot, which is nicely centered on this S, and is nicely placed halfway in the middle of it, of that swoop. Now there's other scars on this, so you could easily just dismiss that, but we've got several of these that are also placed in nice positions. Now the A just so happens to be the angle of this A is at 36 degrees, and that's quite relevant to the geometry. This slanty hyphen appears in the header text of the text proper. It says Shake-Spears, and it's also got a slanty hyphen. I don't know what the slanty hyphen is. The P has got a break in it, which is not normal. Now this A is not at 36 degrees. You know, this line here is not at 18 degrees from the vertical. It's at 21, or at least this bottom section is. And it's got this dirty great big claw on the bottom. What is that? That's just an accident. It's just a bubble. And then the R has got a nice square dot that again is centered on the stem and is nicely placed across the base of it here. Well, that's odd. And then we've got what appears to be a raptor beak on the left of it. This may be an ibis, I'm not sure what this is supposed to be. And there's a gap there on this R, which is definitely not normal. Why we've got a dirty great big R on one of the characters of the headline of this. And then this dot here, and this is perfectly placed on what is the well-defined centre line of this. So my geometry defines the centre line of this, and it goes straight through there. And there's another line that comes up here, which as a result defines the central pixel of that. It's so accurate. So that's strange. And then on the S, again, we've got a dot here in the middle, which is perfectly centered horizontally and vertically. And I know there's lots of other damage on here, but that dot is bigger than any of the other ones, and it's in this regular place like all the other ones. Moving on. This S here has something strange here. I haven't found what that is, if anything. That is far too elaborate to just be an accident, particularly because it's got a vertical line with a zigzag across it, and if you look over here, we've got a zig at the bottom that would fit onto it. I call these the Bluetooth logo. I don't know what they are, but they're worth noting as anomalies on this page, as strange this is. So right, if we move over to the N here, a bit. And this has a bauble at the top, which looks like it's dropped off a Christmas tree. It's sunk slightly into here, and it's got a thing on the edge. What is that? That blob, not with the nice bauble side to it, but a blob here, appears on all other copies. As does the dirty great big gouge in this N. Now this N isn't at 45 degrees. This one is. There's a 45 degree line in the geometry that just goes straight up the middle of this. But what is that gouge? That is on all copies Bodleian, John Wright and Aspley, and it's right in the middle of the page. You know, anybody that's ever looked at this has gone, oh, that's a bit rubbish. Yeah, what's all that all about? The centre line, by the way, goes straight down the inside of this and hits that point there. Moving on to the T, and the left side of it is a bit wonky, and the bottom side is kind of gamified. You know, why have I got a serif on one side and not on the other? I believe there's a dot here. I don't know what it means, but there's a dot there which is exactly on the same level as that dot, and this S should be poking up a bit. If you look at the S over here, it should be nicely pointed in, but it's not. It's sort of smoothed off, and as I say, I believe that these two dots are actually are yet to be decoded. And then we've got another of these little dots which is on the centre line, and again the geometry will define the centre of that nice round dot. I mean, it's got something on the end of it, but this side is very round, very regular. What is that? Is that just some blemish, is it? And then we've got what appears to be a comet-shaped full stop after it. How odd. Right, so let's go down. The N of Noe before is actually less than 45 degrees. The E's are all a bit weird, I'll have you know, and require looking at. There's a scar here, which I don't know why or how that's turned up. I'm fairly sure that's just a digital error on the Folger's otherwise superb copy. I'm not. I thought I'd done that, but it's not. It's on the original from the Folger. Then we've got a capital I. Why have we got a capital I? There's a line on the geometry that runs right up the side of that, but I for Jesus. Why have we got a capital I there? And then we've got a lowercase I here. We've got three lowercase i's. All of the dots on these lowercase i's form part of the geometry, and this one, as you can see, is Homer Simpson. That is Poet Ape, and there's quite an astonishing geometry that goes through there. This may be an aquatic thing. That might be aquatic, I don't know. And then this full stop, if you put a 50-degree triangle and a 52-degree triangle behind it, you'll notice that these lines here are between 50 and 52 degrees. They are intended to signify a 51-degree pyramid. 51 degrees flat, and that's a very relevant number, very relevant angle. Now moving down, we've got the two horizontal rules. The upper one is slightly shorter, and actually it's 2 millimeters not horizontal. I spent a long time trying to work why that is so, and I think I found it. At this end, we've got these dots marked on it. See, that's clearly a dot blodge on the end of that, and there's signs of a sort of a dotty stuff on the end of this. Now, these rules are very raggy, extremely raggy. This centre one floats up in its middle, which has caused some confusion. So those are the two rules, and then we get into the text at the bottom, which is just festooned. So the A here has got a dot on the top. Why has the A got a full stop on there? Quite a large one. Now, if we move across to London, and this N here got quite a boxy serif on this side of it, but this side of it should be pointed, and it's not. It's got a dot on it, and that dot is exactly the same level as the dot on the A and forms part of it. Actually, it's a 45-degree isosceles triangle, and guess what? That N, unlike all the other N's other than the one in the middle at the top, is at 45 degrees. This one isn't at 45 degrees. So there. Right, moving on. This B here, has a very boxy, blocky serif at the top. At the bottom it doesn't. It has a kind of a semicircular one. And my geometry will define that pixel there, right in the middle of that, roughly on the line of this, perfectly. Fancy that. This G, the line of this G here is at 21 degrees. You remember 21 degrees? That's the A is at 21 degrees, and this huge full stop here that's got this side flattened off on it, that side is at roughly 21 degrees. And if I draw a line at 21 degrees perpendicular to that, so parallel to that, from the centre of this point up there, guess where it turns up? I'll show you later. So now I've got the two T's here. The left T is very taurine and quite weird. What is this? This is a highly bespoke character. It's got this gammoness going on again. And this dot here has got a hexagon fashioned onto the bottom, which is rather convenient because I've got an equilateral triangle that's defined from that point, and so that these lines are sympathetic to that. These angles are sympathetic to that. This T is there are typefaces of this kind, but it still looks a little bit weird. But this dot here has got a dad's army arrow pointing at 30 degrees to the vertical, which is odd. The E here is bigger than the E's further up and Noi before, and yet its I is filled in, and there's something to do with these E's which we haven't got to the bottom of. And then on the bottom line, to be sold by William Aspley. The William is all over the show. Why is this so raggy? That line is not parallel to this line. What's this W here? That dot and that dot are both perfectly defined by the geometry. This one has a line straight through it, and my geometry has a vector line that goes straight through that line there. That line is at 36 degrees, and this is a golden rectangle. And then moving along, Aspley, so you do get these swoopy A's, but they tend to be at the start of sentences or in the middle here. And that 30 degree line here will go straight through this kink here in the A, and when you chop that off you get quite a nice 4 there, don't you, if you take that away, which might be of use. And this rather shoddy S, I have a vertical line that goes straight through the break in there, so we now know why that has got a break in it, and there's lots of opportunities for going 4T. And then we got this full stop here, which again seems to have some kind of pyramid thing, and this one's truncated. If you do the 50 degree and 52 degree triangle trick on this thing looks like it's at roughly 51 degrees. A truncated 51 degree pyramid. I wonder where they are, where that is. And then finally on 1609, the eye of the 6 is a very nice circle. That's actually a full stop. That's one of our guide points, and the centre line for this goes straight through the middle of this, exactly through the middle of it. And then next to the 9 we've got a full stop which has a hexagon on its right side, I believe the left side is intended to be semicircular. Again we've got an equilateral triangle coming from here, and therefore these angles are sympathetic with that. And that is the stock check of the funny things on the page. Now, in order to explain what all those markings on the page are, I'm going to draw you an extremely elaborate geometry. Now, it's important to make the point that this geometry is entirely generated by mathematical rules from this spreadsheet that you see. I can muck around with this a little bit, and I can, let's say, move the spot next to the G to the right 1 pixel, and when I do that, this entire thing goes absolutely bananas, because everything is dependent on a previous element. Everything is ultimately dependent on where these two are, and then we work out other parts of the geometry from which we can then derive other things. Now, the start of the geometry is a circle defined by these 2 points, the spot next to the G and the imprinted dot, which define its diameter. And this circle generates these 2 horizontal lines, and the bottom one is the base of this pyramid, which is the central element in the geometry. Now, the way this works is that there are 3 right-angled triangles that intersect with each of with these 3 points, that point, that point, and that point. So this point, and this point. And these 3 triangles create these yellow construction lines. This one defines that point, and then the horizontal line from there is the lower rule, and then there's a parallel line here, which intersects a horizontal line from that A point, which is this. So let's just go through what each of these 3 triangles are. The first one is defined as having a tangent of value pi, so alpha is equal to inverse tangent of pi. If I put a circle with a diameter of this small side, its perimeter, its circumference, will be equal to this long side. Okay, and the second one is a 3, 4, 5 triangle. The ratios of these 3 sides are 3 to 4 to 5. So it has the value beta is equal to inverse tangent of 3/4. And then the last one is slightly more complicated, in that this small green side forms a golden ratio with this small blue side. And so this side is equal to inverse sine of 3 upon 5 phi. Okay. So with those 3 triangles, if I draw a yellow line from this corner of the green triangle up to the corner of the red triangle, where it crosses a horizontal line from the spot next to the G, that defines quite perfectly the full stop after the T. And then if we draw a line from the corner of the blue triangle through that point, where it intersects a tangent from G, that yellow line there is perpendicular to that. That defines the left side of the lower rule. And then the upper rule is defined by a chord, a parallel line to this tangent, and where that intersects a horizontal line from A, that's the corner of the red triangle, that defines the upper rule. This is the Petrine cross that Alexander Ward discovered not long after Green's publication of his circle. Now this is in fact the finale, but I need to define that point next to the tau cross, which is defined as where the corner of the phi triangle, that's where this 9 dot is, where it intersects this horizontal after before passing perfectly through the center point of this diagonal, this diameter, and it runs up the side of the P. I'll discuss that in full later. I just needed to define that P for you. So why do I think that there is a pyramid here with its vertex on that red dot? Well, it's because when I draw a equilateral triangle of the same side length as the base of this pyramid and inverted so that its vertex is down here, then it will intersect each of those 5 S's at quite specific points, and that looks pretty good. There's quite a lot more. I then cut out of this equilateral triangle this golden norm, 36 degrees, 36 degrees, 108 degrees, and that then defines vertices. I had vertices for those two. I've now got vertices for each of these S's, which I say at specific points in those S's, which I'll explain later. Now, within this golden gnomon, you can necessarily stick a pentagon and drop down below it a hexagon, and that is what Albert Dürer called a Vesica piscis. Well, it's to do with the circles. It's a fish bladder. That rather exquisitely runs right through the diagonal of this N, and then the other one runs straight through this gouge on the N. Isn't that funny? Now, this method of deriving a pentagon from a hexagon is imperfect. These lines are not at 45 degrees, they're at 44.98. The hexagon and the pentagon are perfect, and hence if I'd drawn these 2 lines at exactly 45 degrees, I'd have had a wobbly pentagon. So that's nice, but we've got more. You see, this vertex here is exactly above this 9, and that line runs right up the inside of the I of imprinted. That's why we've got a capital I there, I for Jesus. Now, this end of the tau cross isn't defined in my program as being where this circle is, where the horizontal hits the circle. It's actually defined as being a quarter of the way across the base of the pyramid. And it just so happens that these two are almost coincident. They're slightly out, of course, but they're within the resolution of the page. If you draw a 1 millimeter wide line, which isn't very thick, you will not notice any of this. Now you'll notice that the yellow line here is not, that's several millimeters away from the red line. The centre line of Sonnets is not exactly halfway between Shakes-Spears and Noy before imprinted. So the thing about this tau cross now, and the fact that it just so happens to be both a quarter of the way across and intersecting this, terminating perfectly on this circle, is that actually tells us that the perimeter of the hexagon is equal to the side length of the triangle of this big triangle here. The perimeter of that is equal to, well, it's actually 1.002, I believe, of this side. So that's good. So we've got these two properties now, which are similar to the Vesica piscis, which is imperfect. Right. We've got two more things which are imperfect, but they're so close that it seems that these guys weren't quite sure if they were real or not. So, and then we've got another property. We've got this pentagram, which is corroborated by the golden triangle A, and it also clips this T rather importantly. There are 3 lines that go through that T, and originates from the centre point, the midpoint of this of the base of the pyramid, and it almost perfectly bounds this this hexagon, such that this side is bounded by the internal pentagon of the pentagram, and so are these two vertices. So that's, you know, all these properties are irrespective of the page. They're just properties of the geometry. But that's what that's our Vesica piscis, which corroborates the pyramid. Now there are two further triangles that come off these two horizontal rules. On the top there's a perfect 45, 90, 45 degree isosceles triangle, and on the bottom there's a 36, 36, 108 degree golden gnomon. Now the upper rule, as defined by the circle and as on the page, is noticeably smaller than the lower rule, and it should be a little bit more short on this side than it is on that, and that means that the center point, center line of vertical center line of this isosceles triangle will be a little bit to the left, and indeed it is. The center line of the pyramid is through the right of the right foot serif of this N, and this red triangle, its apex is precisely on the stem, and in fact it's also precisely on the exact midpoint between imprinted and Shakespeare-spears. But it also goes perfectly through the monkey's head here, which is along with the two other lines, the Great Triangle, and there's a vertical line down here. Now on the bottom there's our golden gnomon, which just so happens the apex of that is within the eye of the 6. It's not perfectly on the circle, but it's near enough. It's extremely close. And whilst it's necessarily on the blue centre line, obviously, it's not necessarily on this circle. That's a function of the angle between G and imprinted. Now there's a number of corroborating lines and marks to do with this. There's a golden triangle with these two yellow lines, which is coincident with that Y, and with the W, and with the T. But this red line here goes straight through that dot on the top of the eye. So as well as this lowercase I actually having a sympathetic bottom serif just to rub it in. So those are the two extra triangles on there. This one here is one of the series of remarkable geometric coincidences. The star chart, which consists of these three blue lines that are at 63 degrees to the horizontal, and then 21 degrees and 20 degrees to the vertical. Now the Kepler star, which relates to SN 1604, Kepler's supernova is what we now call it, measured by Kepler's assistant, I think it was, at 21 degrees and something. So we're going to round it down to 21 degrees, which is exactly what the angle that this G is at, and it is going to arrow through this claw on the foot of the A, and I'm going to terminate it on the centre line of Shakespeare-spears. So that's the first one. Now 63 degrees and 20 degrees were both measured by Brahe. Now Brahe, when measuring the supernova named after him, Tycho's star, he got it slightly wrong. He got it nearly 64, but just under 63 and 51 minutes, I think it was. Now, if you look up on Wikipedia, it will say it's just over 64. But fortunately, Brahe wrote down his measurement, of course. It's been recorded, and if you hunt a little bit, you can find that. So I was quite delighted to do that. Now, when you extend that line, it's defined from this point, which itself is defined. I haven't shown you how it's defined yet. I'll do that later. But if you extend that, it will just about hit the eye of William. It's slightly south of there. Right. Now the 20-degree line, we think, it looked like it ought to be the third of these three major astronomical events. We've got two supernovas and then this great comet of 1577. So I assumed that this was when it would have exhibited an occultation with some constellation. And if you look on here, this line goes straight through that comet-shaped stop there. So, and finally, I managed to find a translation of Brahe's German write-up of this, and in it, on the very first sentence, it says that a comet appeared in the constellation of Capricorn. So we look at what the declination of Capricorn is, and of course it's 20 degrees. So now when we extend that back in the other direction onto the golden gnomon, it goes straight through that other eye, and the serif of that eye is also sympathetic with this 36-degree line. I'll show you that in greater detail later. Okay, so we've got these two stars as well that have got this further corroboration here. But the really profound thing is that this Kepler's triangle, which has its right angle vertex defined as where this 21-degree line hits the great triangle here. And if you extend this side of the triangle down to where it intersects this circle, a vertical from here, this is out by 3 pixels, a vertical from here down to there will intersect on the circle, and I've just done the green and the blue lines here, but you can see that the green line is almost nearly through this kink here, and you can see if you chop this swoop off, you get a nice 4 there. And there's also a strange gap in the S. We go straight through it. Now that's the next of a series of quite bizarre geometric coincidences of this model which have been identified. So that's the star chart. I've got these 3 lines which have all got this corroboration. This one hits the dot at the bottom of the S, this one hits the dot in the middle of the S and goes through the comet. This one is sympathetic to that, but also creates this astonishing 30-60-90 triangle, which is perfectly coincident with the circle at the bottom. And as you can see, this vertical intersects this T at exactly the point, not just where that diagonal of this quadrant clips the serif of the T, but also, I'm not showing it on here, but exactly at the same point, within 1 pixel, within 5 1/1000ths of an inch of where the great pentagram clips that T as well. This one's quite bizarre. And also these 3 lines, the little triangle that's created by these 3 lines is entirely within our monkey's head. So isn't that remarkable? The strike through of Neue before imprinted is exactly half the distance across the Great Pyramid or the Great Equilateral Triangle, half the distance across it below it. Therefore these are necessarily 2 squares. Now from the corner of this square here there is a precisely 15-degree line up to this tiny little dot that we've been playing with next to the R. And that means I can drop a threepenny bit in there. And the reason I want to do that is because if I extend, as I extend that line, if I extend this line onto here, this line onto here, this line onto there, and then I do the same with 2 at the bottom here, that line across to there and that line across to there, I can chart out a triple tau. Now this symbol is absurdly appropriate. It's you've got the standard Freemason symbol on the left here, this thing, if you weren't aware of it, is the symbol for Royal Arch Freemasonry, and I would say that symbol is the second most prominent symbol within Freemasonry. I called this bit the Golden Saltire, which is a rubbish name because it doesn't actually have pentagonal angles on it, but we'll go with that for now. The reason for that is because it goes through what we call the ore point, which is the centre line of Neue before, and there is a precisely 60-degree line from that point, that determined point, that goes down and hits right in the middle of this dot at the foot of the B, where that line intersects the horizontal from the G and through the T dot. Is the foot of this line. Now, what was recently discovered is that there is a perfect equilateral triangle via the dot next to the Taurine T, such that the vertical from its apex goes straight through the A, so that's a considerable corroboration of this line. Now, the reason I need this diagonal line here is because I need to be able to reflect that point across the centre line of R in order to make this evening star point. So I've been, along with the fact that we've had this suspicious dot at the bottom of the B, I've been fairly happy with that line. It's just that I don't have enough geometry to go with it. So this triangle at the bottom has improved that, but also I noticed that we've got R and R here, and this line here doesn't obey the rules, the normal rules for intersection with that A, because it charges across it. But it does in a very neat way, in that it crosses it symmetrically. And on top of the fact that we've got this A, I'm happy that that is all there, but I think there's a little bit more to it. So this R here with its raptor beak is very much Horus, and then this dot here has got a hexagon across its bottom. So that's the Golden Saltire, and then so with that is that in order to make the dot at the bottom of the R, we reflect the top of this, which is defined as being at the same height as the pentagram, and that just so happens to give us that dot precisely. Now again, that's a little bit vague. I'm sure there should be more corroborating geometry around there. But if we then draw a perfect 23-degree line, and of course 23 is the declination of Venus as an evening star in 1609, then it will intersect with this square, which I've seen drawn on the Vesica piscis, along with the triangle in the middle of there, but that square goes straight through that dot. It goes up the outside of that stem. It goes on the left side of that stem and straight through that dot, and this perfect 23-degree line ends up exactly in the middle of that circle. So that's the evening star, and the last of our 5 measured angles. Now let us return to the Chi-Rho, which is in red here, and the message that it gives. So this points, in the order that you would write it, to by God, by G, by golly, by gosh, but let's go for by God. There are other things it can be, and in that order, and in you get, if you pick 2 characters at each point, you get DE, we're at the end of the word there, so that's all we can have. VE in either direction. Then we've only got an A on the left, so RE. And this in the middle is a plus sign. Now the plus sign was devised by Robert Record, but he died 2 years after he published. It was D that republished his works and popularised that symbol. And so this says, by God and De Vere. I'll leave that to the authorship debacle to debate, but it means that you cannot let this geometry out of the bag because it will end up pointing at this. Now, Waugh also discovered that there was this large red triangle here with a dot on the left. Now, Dee liked to write his name backwards. He's done so at the top here, D dot, and this is a reversed delta dot. Reversing is a very standard, simple form of obfuscation which Dee used, and there's plenty of examples of it. Now there are two corroborating triangles, this green one and this blue one, so allow me to justify that. This green triangle is defined as being from that point there, the dot next to the 9, which has been derived by the phi triangle, and this side is coincident with this arrow head here. That's actually a golden gnomon which is pointing in this direction in 30 degrees from the vertical, and it just so happens that this green line goes straight through a kink in the swoop of the A and chops off a nice 4 there. Now the M on this side is also sympathetic to this slope, and there is a hexagon cut on this side, but the important geometric coincidence is that apex there is almost perfectly coincident with the right vertex of this blue triangle. This blue triangle, which is a perfect 45, 90, 45 degree isosceles triangle, has this apex defined as where the circle, as per the geometry, defines the centre point of this upper rule. Now this upper rule is bent, that's just a fact. It floats up from this point here up to here and then comes back down again. I don't know why it's done that, but also by my calculations it's just under half its width too high. It's been set slightly too high to fit with my model. So if you add those two together, if you move that down essentially its entire width, you will get the centre of it being on that point. Now the A and the N are slightly too high because this triangle has been set to that point there. You'll notice the angstrom A is huge. It's bigger than any of these other full stops other than that one. And on the other side there is in fact a little dot there instead of the serif that's on this N, and this N is a little bit fatter than that N, and that line there is at exactly 45 degrees. It's that N as well, but that's at exactly 45 degrees, and as I say it's coincident with this, and that we've got our Chi-Rho line from that corner that hits the apex of the large red triangle. So the order that these go, well, it's either the blue or the green or the green and the blue, and then the red one is the finale, and so you draw that triangle and you end up back at the spot next to the G, which signifies God and is the beginning and the end of the diagram, which I find quite nice. And so that is the basis of the geometry.
I wanted to explain the architecture of William, because we now know why this thing is quite so wobbly, and we've got justification for each of the characters. So the W, the left side of the W is at 18 degrees, which is what this T is as well, and also what that Y is on the other side, and is part of a golden triangle within a golden gnomon. This line here that goes straight through that dot is defined as being through there, is at precisely 20 degrees, goes straight through the comet and lands on the star in the centre of the rightmost S of Shake-Spears, and goes straight through here, hits the golden gnomon, and that eye is sympathetic with this line of the golden gnomon. This L is at 25, I don't know why it's at 25 degrees to that dot, but it's an absolute 25 degree line to there. And there may be a coincidence actually with this line, which is the line from the phi triangle to the imprinted dot, and it runs nicely along the side of this second T, and if you draw a parallel line on the other side of the bottom serif of this T, it will perfectly bracket that A. That A is roughly at the same angle as this. This angle is a irrational angle, and then this M is therefore what we can say is quite likely to be sympathetic with this 30 degree line here, and then obviously we've got the swoop on the A, but it's this William that I wanted to show you. This geometry begins with these three Keplerine triangles that generate the two anonymous horizontal rules. We then have three 51 degree pyramids, this huge one in the middle of the diagram, but these two full stops after imprinted and aspally are also 51 degree pyramids. We have three golden gnomons. We've got this one at the bottom that's beautifully defined, we've got this one that generates the Vesica piscis, and indeed there's a golden gnomon on the dot after the second of the two T's. We have three equilateral triangles. This huge one here, we've also got this one in the what I'm calling the golden saltire, and there's also this green one on D's triplicate signature. Now there's also these two equilateral triangles which I've discussed before on previous presentations. They're in there, but they're intrinsically connected to this green triangle. Multiply the blue line by root 3 and you get the green line. So they're too close to that, and I've got three. The problem with that argument is that I want both of these squares, because I use these squares in tracing out the triple tau. And then I reckon I've got a third square which is within the Vesica piscis. And I've got three hexagons. I've got the hexagon of the Vesica piscis, and there's a hexagon on the bottom of the tau dot and the side of the 9 dot. And I've got the three astronomical events of the era, the three quite remarkable astronomical events of the era: Kepler star, Tycho star, and the great comet of 1577. Now I only have two right-angled isosceles triangles, both beautifully defined, but I need a third, and I've no idea where it is. It may be part of the geometry. If it is part of the geometry, it won't. Not only will it be connected to it, and therefore I can generate it, so I can add an extra line in my spreadsheet, but it will be multiply connected. It won't just be hanging off the edge. If I've got something just hanging off the edge that doesn't do anything, I have to start getting suspicious. And we've only got two pentagons to my liking. We've got this pink one here that's part of the Vesica piscis, and then the great pentagram, its internal pentagon bounds the hexagon. Now I know you can make another pentagon around the outsides of this pentagram. There are an infinite number of them that I can make like that, so again that would be too closely associated with it. I need another pentagon somewhere. I don't know where it is. Now, of things that aren't there is this.
and I spent nearly 6 months, I think, trying to tell you that that existed. It doesn't, to my mind now. The real reason that I know it doesn't exist is because it didn't start doing anything else, and everything else started integrating in at least 2 ways with the rest of the diagram. I thought this was the underline of Shake-Spears, but it's not. There's nothing specifically to corroborate any of this, and so that was my greatest sin. I can only gloss on that by saying that I was managed to able to identify that it's not there. Now, what are there? I believe are these 3 crosses: the Tau cross, the yellow Tau cross, the green Petrine cross that Alexander discovered, and then this red cross. Which looks fairly blatant, but you know, you can make a cross. We can make a cross through Sonnets, couldn't we? If we felt like it. So this is better balanced, I would argue, but and it's got these 3 S's. What I've been desperately trying to do, and hence why I kept hold of that other pentagram for a little bit longer than I should have done, is that I'm trying to make a inverted pentagon appear over that S somewhere, so that I can put a Tudor rose on it and make that a rosy cross. But that's the end of my 3s.
Right, I'm afraid I've lied to you. I told you that all we needed was the spot next to the G and the imprinted dot, the X and Y coordinates of those 2, so just 4 numbers to predict the entire model. Now, as you can see, these red lines overshoot the base of this pyramid here, which they're supposed to be predicting. So these vertical blue lines, and so I have to correct those. So I need these two X coordinates. So that's 6 numbers in total. Now, the reason that I know that that's where the pyramid should be is that when once I've worked it out, that the tiny little dots on the strike through of Shakespeare's and of Sonnets, which are both predicted perfectly. There's an intersection here at precisely 15 degrees from this point, and then this one is exactly 1/3 of the way across the page, across the bottom of this, from this vertical. Now, what this has also shown me, what I've now started to realise, is that while there is logically a circle at the bottom, you're intended to look at it as this spot next to the G as being the beginning and the end with the signature of the diagram, because doing it in the other direction, the maths is really crazy, but and it's difficult to do. Whereas this is at least logical. We've got a way of doing it, and so all of these points, including, interestingly, this 9 dot, which I correct with a shift and stretching factor of what I have to do to get this. This side is out by a teeny bit, so we have to shove a little bit across there, and then we shove that same amount here, and then we scale the whole lot. And if I apply that transformation onto where I'm predicting that dot to be, which should actually be on its left side, when I apply that minor transformation, I get this being predicted to 1 pixel of where the armpit of the Vesica piscis is, and I get sensational accuracy. Here's the Venus dot here. It's all over the page once I've done that, so I know that's correct, and in turn it's allowing me to kind of prise open exactly how this is set, but it's not set with a pair of compasses on the centre of the circle, as it seemed obvious to begin with.